One of the most important types of potential energy in chemistry is the energy that is stored in bonds. That is known as bond energy. Sometimes it's known as chemical energy. And the way we measure this energy is by determining the minimum amount of energy required to break a given bond. And the units we use to describe that is kilojoules per mole. Now, when we break a bond, energy is required to pull the atoms apart. And when a bond is formed, that same amount of energy is actually released. So let's look at the simplest covalent bond, which is the single bond between two hydrogen atoms. If two hydrogen atoms come together to form a hydrogen single bond, 436 kilojoules per mole is released. When bonds form, the atoms become more stable and energy is released, usually in the form of heat. If we break this bond, then we need 436 kilojoules per mole to break the bond. So I just want to point out this positive and negative with respect to the energy. When we see a negative sign in front of an energy, that means that energy is being released or given off. If we see a positive sign, that means that energy is required. So on this table here, we see a variety of bond energy. So the minimum amount of energy required to break a specific bond. And the units here are kilojoules per mole. And I just want to point out the difference between single, double, and triple bonds using the carbon-oxygen bond. The carbon-oxygen single bond requires 336 kilojoules per mole to break it. The carbon-oxygen double bond requires more than twice the amount of energy of the single bond, 745 kilojoules per mole to break that bond, while the carbon-oxygen triple bond requires 1,077 kilojoules per mole to break it. Now, if these bonds were formed, then this is the amount of energy that would be released upon the formation. So when chemical reactions occur, bonds break and new bonds form. And we see the two-dimensional structures of methane, oxygen, carbon dioxide, and water in this reaction, the combustion of methane. So for this reaction to occur, the carbon-hydrogen bonds must break, the oxygen-oxygen bonds must break, so that's going to require energy, and then the carbon-oxygen bonds form in carbon dioxide, and the hydrogen-oxygen bonds form in water, and energy is released. So most chemical equations, when they occur, will actually end up releasing energy. Breaking the bonds requires energy, forming the bonds releases energy, and usually there is a net release of energy, and that energy is usually released in the form of heat.